In this video, we are going to learn about 3.2 Nernst Equation. At the end of this lesson, students should be able to use Nernst Equation to determine cell potential, concentration or partial pressure of a species, or equilibrium constant K when E cell is equal to 0. And lastly, predict the spontaneity of a cell reaction. We can use Nernst equation to find the following: calculate cell potential, calculate concentration or partial pressure of a species, and calculate equilibrium constant K when E cell is equal to 0. First, to calculate cell potential. In the following example of a certain zinc-copper cell, the ions concentrations are 0.01 molar for Cu2 plus and 1 molar for zinc 2 plus. What is the cell potential if the electrochemical cell perform at 25 degrees Celsius? If we look at the value of E0 reduction between Cu and zinc, we know that Cu will become the cathode, while zinc will become the anode. So, we write first the equations at anode and cathode. Then, if we refer to the formula E0 cell equal E0 cathode minus E0 anode, we will get the value of E0 cell, which is positive 1.10 volt. Then, if we use this value of E0 cell in the Nernst equation at 25 degrees Celsius, we will get the answer for cell potential E cell. Substitute the information into the formula. Recall that from the overall cell reaction that we have written before, the zinc 2 plus becomes the concentration of products and Cu2 plus becomes the concentration of reactants. And there is no power because there is no coefficients in the overall cell reaction. So, we substitute the other values into the formula and we will get the answer for E cell, which is positive 1.04 volt. Next, using Nernst equation to calculate concentration or partial pressure of a species. Example, a voltaic cell consists of a standard hydrogen electrode in one half cell and a Cu/Cu2 plus half cell. Calculate concentration of Cu2 plus when E cell is 0.25 volt. Okay, so based on the E0 reduction potential, we know that the cathode must be Cu and the anode belongs to hydrogen. So let's calculate the E0 cell first. Write down the equation at anode and then the equation at cathode. Cancel both electrons at anode and cathode and write the overall cell equation. And then, by using the formula E0 cell equal E0 cathode minus E0 anode, we will get the value of E0 cell is positive 0.34 volt. Now, pay attention at the overall cell equation. Notice that there is hydrogen gas and Cu2 plus aqueous at reactants, and at product we have 2H plus. So the expression of Q would be concentration of H plus to the power of 2 over concentration of Cu2 plus and pressure of hydrogen gas. Most students forgot to write for pressure because they think we will only consider aqueous solution, but we also include gas. So the expression will be like that. Then we use the Nernst equation to find the value of concentration for Cu2+. Substitute the other values into the formula and we will get the concentration for Cu2+ as 9.1 times 10 to the power of -4 molar. Next, using the Nernst equation to calculate equilibrium constant K when E cell is equal to 0. For example, when a voltaic cell stops working, the system reaches equilibrium. Calculate the equilibrium constant of a voltaic cell consisting of a nickel electrode in one half cell and an iron electrode on another half cell at 298 Kelvin given the equation and the inert reduction potential as follows. So, what does it mean when the question tells us the voltaic cell stops working? This means that the E cell is equal to 0. The system already reached equilibrium, no more energy release, the cell can do no more work, which means the battery is dead. So if you are told the battery is dead, it means that the value of E cell is equal to 0 and the expression Q is equal to K. So let's solve the examples problem. First of all, we write the equation at anode and cathode. As you all know, the anode must be the more negative inert reduction potential, which is -0.44. When we reverse the equation, it becomes positive 0.44. And then the equation at cathode, and we find the value of inert cell using the usual formula, and we get positive 0.19 volt. And by using the formula for Nernst equation, where E cell is 0 and the expression Q can be replaced by K, we will get the value of K. Last but not least thing that we can do with Nernst equation is to predict the spontaneity of a cell. For example, predict whether the following reaction will proceed spontaneously as written at 25 degrees Celsius given the concentration as follows. First of all, we split the overall cell reaction given into anode and cathode. From the equation, the anode belongs to cobalt and cathode belongs to ferrum. From the table of electrochemical series, we find that the value of inert reduction potential for cobalt is -0.28 volt, while for ferrum is -0.44 volt. So, by using the formula E naught cell equal E naught cathode minus E naught anode, where the cathode is ferrum, -0.44, minus anode for cobalt, -0.28, and we will get the answer, -0.16 volt. So, we substitute this value and the other values into Nernst equation at 25 degrees Celsius, and we will get the value of E cell as -0.14 volt, which means this value is a negative value. So negative value means that this reaction is not spontaneous. So that's how you use Nernst equation in calculations problem. That's all for this video. Thank you.